the required parabola to be fitted to the given data, y is equal to a plus bx plus cx square. So give equation number 1 for this. So this is assumed second degree polynomial or parabola to the given data which is to be fitted. Now here how many x values are there? 1, 2, 3, 4, 5. So x and y values are 5. That is n value is here 5. Now how many parameters are there? A, B, C. So these three are parameters. Here A, B, C are parameters. So now definitely we have here three normal equations as we have discussed in previous class. So tell me, what are these three linear equations? What are these three linear equations or normal equations? The normal equations for desired polynomial are, what are these, ma? Summation. See the previous class and procedure. See the procedure under the least squares approximation for a parabolic fit. Summation y is equal to NA plus B into summation x plus C into summation x square. And the second equation is summation xy is equal to A summation x plus B summation x square plus C summation x cube. And the third equation is summation x square y is equal to A summation x square plus B summation x cube plus C summation x to the power 4. So these are three normal equations. Give equation number 2. Now we have to find the summation values. So find the required values, that is summation x and summation y and summation x, summation xy, summation xy, and then summation x square, and then summation x square y, and summation x cube, and finally summation x to the power 4. So find all these values. We have to find all these values. These values are calculated as follows. According to the table, we can find these values like that. So we know that x and y values from the given data. What are the x values from the given data? 0, 1, 2, 3, and 4. And similarly, what are the y values from the given data? 1, 1.8. Tell me, ma. 1.3, 2.5, 6.3. And now we are going to find sum of all the x values, sum of all the y values, and summation of the required values. What are these? Some x into y. First, to get the summation xy, first we have to find x into y value. X into y, product of x and y. Tell me, ma, x into y, 0 into 1, 0. 1 into 1.8, 1.8. 2 into 1.3. Use calculator if you need. 2.6. Next, 3 into 2.5, ma. Value is?
9.5.
7.5.
7.5.
Next, 6.3 into 4.
25.2.
25.2. Very good. Next, what will we get? Summation x square. For that, we have to find x square values. So, x square. Take square for x values. 0 square, 0. 1 square, 1. 2 square, 4. 3 square, 9. 4 square, 16. And similarly, we are going to take x square into y for this. X square into y. X square, this is x square, this is y. So 1 into 0, 0. 1.8 into 1, that is 1.8. Next, 1.3 into 4, 5.2. Next, 2.5 into 9. Use the calculator. Tell me what is the value?
22.5.
Very good. 22.5. And next, 6.3 into 16.
100.8.
Very good. 100.8. Next, what is the remaining values? X cube. 0 cube, 0. 1 cube, 1. 2 cube, 8. 3 cube,
27.
27. 4 cube,
64.
Similarly, x to the power 4. 0 to the power, x to the power 4 means x cube into x. X cube and take x cube into x. You can 0 or 0 power 4. Anyone you can take. You can follow anyone. X cube into x. 1 into 1.
1.
8 into 2.
16.
3 into 27.
81.
4 into 64. 256. So now we are going to find the sum of all the x values, sum of all the y values, sum of all the xy values, sum of all the x square values, sum of all the x square y, sum of all the x cube, sum of all the x to all the values of x to the power 4. So that is summation x, sum of all the x values. What are these values, ma? The summation x means sum of all the x values.
10, madam.
10. Summation y means sum of all the y values.
12.9.
12.9. Summation xy, all sum of all the xy values. 37.1. Is it right?
Yes, madam.
37.1. Next, summation x square, sum of all the x square values.
30, madam.
5, 30. Next, sum of x square y.
130.3, madam.
130.3. Next, sum of x cube value.
100, madam.
100. Sum of x to the power 4.
354.
354. Very good. Next, what will we do after getting all these values?
Substituting, madam.
Yeah, we have to substitute all relevant values in our normal equations, these three. I'm going to take another page. Substituting all the relevant values in the normal equations. We get summation y. What is summation y? So according to the first equation, summation y is equal to NA plus B summation x plus C summation x square. Summation y means 129 is equal to n. What is n, ma? 5. 5a plus summation x value 10b plus summation x square 30c. So give equation number 3. So according to the second normal equation, substituting that relevant values from the table, summation xy 37.1 is equal to a into summation x, that is 10a, b into summation x square 30b, c summation 100c. Give equation number 4. Next, according to the third normal equation, substitute the relevant values from the table. Summation x square y 130.3 is equal to a summation x square 30a, b summation x cube 100b plus c summation x to the power 4
354.
c. Give equation number 5 for this. So anyway, there are 3 equations, normal equations. Now we are going to, these 3 are linear equations in A, B, and C. These 3 equations are linear equations in A, B, and C. So these equations can be solved. So now to find the values of A, B, and C, we have to solve all these 3 equations. Okay, these 3 equations can be solved. First, to take 2 equations and solve these 2 and avoid A term and get the equation in B and C. Solve these 2. First, to take first 2 equations, 3 and 4. Equation 3 is multiplied with 2. Do like this. Equation 3 multiplied by 2 is equal to, and equation 4 is equal to. Take this one. After getting this, tell me. 3 into 2, equation 12.9. So 12.9 into 2, ma?
$25.8.
Yeah. From 3 and 4, we get
25.8.
25.8 equal to 10A plus 20B plus 60C. And the equation 4. 37.1 is equal to 10A plus 30B plus 100C. So both terms get cancelled. Subtract these two equations and tell me this value. This value. Minus 37.1 minus 25.8.
11.3, madam.
11.3 is equal to minus 10B.
Minus 10B.
Minus
40C.
So give equation number 6 for this. So next we go to take equations 4 and 5. So to avoid eighth term, the first term, equation 4 is multiplied with 3 and equation 5. 37.1 into 3 value, ma?
111.3. 111.3.
Okay. Next, 30A plus 90B plus 300C. Next, fifth equation will come as it is. 130 into 3 is equal to 30A plus 100B plus 354C. And subtract both the equations. 130.3 minus 111.3 value.
19.0 means 19.
Okay. Next, minus 10B minus 54
C.
54C. Give equation number 7. Now, equations 6 and 7 are in B and C. So, if you solve these two equations 6 and 7, we get any one value from B and C. Next, solve equation, equations 6 and 7. We get what is equation 6? Minus 10B minus 10B. So directly you can take equation 6 and 7 equations. So I am going to take another page. Write equation 6 and 7 and find any C value. What is equation 6? Minus 10b minus 40c is equal to minus 11.3. And seventh equation is minus 10b minus 54c is equal to minus 19.0. So what is this value? 14c is equal to
7.7.
7.7. Okay. So 14c is equal to 7.7. C is equal to 7.7 by 14. What is this value? (7.7) divided by 14.
0.55.
0.55. Very good. Therefore, C is equal to 0.55. So from C, we can get B value from any equation 6 or 7. Substitute C value in the equation 6 or 7. So from equation 6, minus 10b minus 40 into C value is equal to minus 11.3. So minus 10b is equal to minus 11.3 plus, what is this value, ma? 40 into 0.55.
29.70.
29.70. 0.55 into 40 value is 0.55 into 40 value, ma?
Oh,
22.
sorry.
22.
22, ma.
నేను ఈక్వేషన్ 7 లో సబ్స్టిట్యూట్ చేస్తున్నాను.
Okay, okay, ma. 22 minus 11.3.
$10.7.
10.7. So minus 10b is equal to 10.7. B is equal to minus 10.7 by 10. What is this value?
1.07.
1.07. 1.07. So B is equal to minus 1.07 minus. So therefore we have B and C values. So using these two values, we can find A value. If you substitute these B and C values in any equation, in any equation, normal equations. So what is the number? This one. So substitute B and C values in equation 3 or 4 or 5. We can get A value. So from equation 3, we have what is equation 3, ma'am? 12.9 is equal to 5A plus 10B plus 30C. So now simplify this equation. 5A is equal to minus 12.9 minus plus 1.07 into 10.
10.70.
10.7 minus 0.55 into 30. What is this value?
16.5.
Yes, 16.5. And now simplify this value. 12.9 plus 10.7
7.1.
7.1.
1.
What is this value? 12.9 minus plus 10.7 minus 16.5.
7.1, madam.
7.1, is it right?
No, madam. 7.10.
7.10. That means same, 7.1 or 7.10. So what is A value? 7.1 by 5. 10.7 minus 16.5 is equal to 7.1. 7.1 divided by 5 is equal to, what is this?
1.42.
1.42. So therefore, A value is 1.42. B value is
minus 1.07.
minus 1.07. C value is 0.55. So now substitute all these values. Substitute all these values of A, B, and C in equation 1. We get what is equation 1? Y is equal to
A plus bx plus c.
A plus bx plus cx square. So y is equal to, what is A value? 1.42 plus B, that is 1 minus 1.07x plus C, 0.55 x square. So this is the, what is this? This is the required parabola or second degree polynomial to be fitted to the given data So this is our required second degree polynomial, which is to be fitted to the given data by using the least squares approximation method. This is the example problem.
Small doubt. Madam, shall I allow the calculator in the examination?
Yeah, definitely for numerical methods, ma'am.
Okay, madam. Thank you.
So next, page number 97 in your book, do that problem. Page number 97. Do that problem, homework. Okay, now I am going to take another method. So that is, so far we have completed the, according to the straight line or first degree polynomial or second degree polynomial or parabola. Now we are going to take another form which is to be fitted to the given data. So what is that form? Exponential form. So now by using the least squares approximation. So now first of all, we have to see that the procedure of that method, and after that we have to take example under this. Next we go to take least squares approximation. For fitting the curve in the form of y is equal to a into x to the power m, where m is a fixed number, any number, fixed one, whatever it may be, fixed number. We know that a is a parameter. So now we have to see the procedure of this one in the form of curve y is equal to a into x to the power of m, which is to be fitted to the given data. So now given data is x, I, y, I, where I is equal to 1, 2, 3, and so on, comma, n. So that means x1, x2, and so on, comma, xn are the x values, and y1, y2, and so on, comma, yn are the y values. So this is the given tabular values, given data. Now we have to find least squares approximation. For the curve in the form of y is equal to, or f of x is equal to a x to the power m. M is a fixed number. We know that a is a parameter. Next, let y is equal to f of x is equal to, this is the given curve in the form of a into x to the power m. M is a fixed number. So remember this point, it is not a parameter. M is not a parameter. It is a fixed number. It may be 2, 3, whatever it may be the number. But A is a parameter. It can be changed itself. But M is a constant, some constant value. That means fixed number. Let y is equal to a into x to the power m be the curve to be fitted to the given data. So what is the given data? This one. To the given data. So now, what is the procedure? How to fit it? So suppose the given function is in this form. How to fit this function to the given data? How to, by using the least squares approximation method. So for that, suppose the given function is in this form. So now to fit it to the given data, we have to take logarithm on both sides for our convenience. Whenever the given function is in this form, taking logarithm on both sides of, give equation number 1 for this, or sorry, this one, for this one. We get log y is equal to log of a into x to the power m. So what is the log a into b? Log AB formula. What is log AB formula? Log A plus log B. Okay. So use this formula like log A plus log B. Log A plus log B. What is log B? X to the power m. So now this is equal to log A plus. So this is in the form of log x to the power n. That is n into log x formula. That means m into log x or log A to the power b. B into log A. Log A to the power b. B into log A. So this is the formula. So apply this formula to get it. So anyway, log y is equal to this one. Give equation number 2 for this one. Now, this is in y, this is in x. M is, we know that any constant number or fixed number. A is a parameter. So this is in this form. So, but if it is in linear form, we can find, if it is in linear form, we can get the normal equation to get the value of parameter. It is not in the linear form. First, we have to convert this into the linear form. So that means the concepts which we have discussed, that y is equal to a plus bx or y is equal to a plus bx plus cx square. So a plus bx is in the first degree polynomial, it is in the linear form. That means a plus bx plus cx square is the second degree polynomial. Anyway, it is in the linear form. So that means if the function is in that form, we can have the normal equations to find the values of parameters. But if the equation is in this form or in this form, we cannot find the values of parameters because there are no normal equations for that kind of equation. So that is why we have to convert this equation in our convenient form, that is linear form. That means it may be a first degree polynomial or it may be a second degree polynomial. Here, for getting that, I am choosing this log y denoted by capital Y and log A denoted by capital A and log x, this log x denoted by capital X. So now, if log y is equal to capital Y, log A is equal to capital A, log x is equal to capital X, then equation 2 becomes I'm going to take another page. Equation 2 becomes then y is equal to a plus m into x. Is it right? Give equation number 3. So now we can say that this is the equation of a straight line in x and y. So if you observe that this is in the form of y is equal to a plus bx. Is it right? So this is the first degree polynomial or straight line. So now it can be fitted to the given data by using the least squares approximation, which we have discussed earlier. So for that, we have the normal equations. So because these normal equations are useful for finding the values of A and B. So according to this one, what are the normal equations? Well, anyway, we have the normal equation. So this is in the form of y is equal to a plus bx. Is it right? This 3 is in the form of y is equal to a plus bx. So that equation 3 is the straight line in x and y. This x, capital X, capital Y. Okay, x and y. So now this can be easily fitted by using the method of least squares approximation. Because this is in the form of y is equal to a plus bx. So anyway, for that, what are the normal equations for this one? What are the normal equations for this one? For y is equal to a plus bx, if it is a straight line to be fitted to the given data, the normal equations are summation y. That means I equal to 1 to n is equal to n a plus b summation x, I equal to 1 to n. If you see the previous class, the normal equations, how many normal equations will be there for this one? How many, ma? Two. Because there are two parameters. Two normal equations will be there. So what are these from the previous class? This is the first normal equation. And the second normal equation is summation xy. From I is equal to 1 to n, a summation x plus b summation x square, I equal to 1 to n, I equal to 1 to n. These are two equations. So here we have two parameters. To find the values of these two parameters A and B, obviously we have two equations. If there are two equations in A and B, then only we can find the values of A and B. So that is why here we have two normal equations. Now, if you coming to here, y is equal to a plus mx. This is in the form of y is equal to a plus bx. How many normal equations will be there for this one? How
Only
many? Huh?
Two, madam.
Two. Why?
A and B, only two parameters are there.
So here capital A is a parameter in this one. And what about m? It is not a parameter from the hypothesis. It is a fixed number. It may be 2, 3, or 5, or 6, whatever it may be. This is a fixed number. It's not a parameter. Only A is a parameter in this one. If it is in this form, even though only one parameter is there, that is capital A. So here we need only to find the value of this capital A. So that means we need only one normal equation to find the value of this capital A. So what is that? Was one normal equation? This is the first equation is n. Okay. So now according to equation 3, the normal equation is, okay. That means we can write it as the normal equation of equation 3 is summation I is equal to 1 to n, y is equal to, what is here ma? Y. What is this y? Capital Y.
Yes, madam, capital Y.
Capital Y is equal to n a plus, what is A my here? Capital A. For this A, capital A. Plus B. What is B here?
Small m.
M.
Summation.
I is equal to 1 to n. What is x here? Capital X. In the place of small y, we take capital Y. In the place of small a, we take capital A. In the place of B, we take M. In the place of X, we take capital X. So anyway, this is the normal equation for equation 3. So next, give equation number 4 for this one. So now, what is the purpose of this normal equation? To find the value of this one. We know that n value, the number of x values or y values from the given tabular values. We know that m because it is a fixed number. So we have the x values, so that we know that summation of x values. We have the y values from the hypothesis. so that we know the summation y value.
Yeah.
And we have to find only the a value. Only a is there. Every value is known. Summation y, we have n, we have m, we have summation x, we have. So that we can find the a value. So that means we can write it as from equation 4, a can be determined. That is, a is equal to, NA is equal to summation y minus m summation x. Therefore, a is equal to 1 by n into summation y minus m into summation capital X. Or you can write like this, I, yi, xi, I equal to 1 to n, I equal to 1 to n. You can write like this also. So this is the a value. So now what is our form? Y is equal to a x to the power m, small a x to the power m. This is capital A. Can we find small a value by using this capital A? Can we find it or not? See the previous page. So we assumed that capital A is equal to log A. So from this one, if you know the capital A value, definitely we can find the small a value. After getting small a value, we can substitute small a value in our assumed form a into x to the power m, which is going to be fitted to the given data. Is it right, ma? Now, small a can be determined from capital A. That is, capital A is equal to log A, which implies that A equal to, tell me ma, what is A? Small a? E to the power capital A. Formula.
Yes, ma'am.
Log A is equal to B, log A to the base E. That means A is equal to E to the power B.
Overwriting is there, madam.
Okay?
Overwriting, madam.
Okay, sorry. This is not our page. This is our page. You know that. Okay? Here you can write. Now, A can be determined from capital A. That is, capital A is equal to log A to the base E. So from this one, we can find A, that is E to the power capital A. So you can apply the formula log A to the base E is equal to B. That means A is equal to E to the power B. This is the formula. Apply this formula, you can write it. Now, A, you can substitute A value. Now you can substitute A value in y is equal to A into x to the power m. So this is known as the, after substituting A value in this one, we can say that this is the required form which is to be fitted to the given data. Next, we go to take example here. Given the following data, and the prescribed curve to be fitted f of x y is equal to, or f of x is equal to a into x square estimate the value of a by using the method of least squares. Approximation. Given data is x values and y values. X values 4, 1, 2, 3, 4, 6, 10, 8. This is the given problem. First, what will we do? Already the function is given in the form of y is equal to a into x to the power m. So our required curve, which is to be fitted, is this one. Y is equal to a into x square from the problem. Now we can say that this is in the form of y is equal to a into x to the power m, where m is equal to 2, this one, m is equal to 2. We know that n value. What is n value? 1, 2, 3, 4. How many x values or y values? 4. X and y values are 4. That is n is equal to 4. So now, according to the procedure, now to find the value of, what is a here? Parameter. What is a? A is a parameter. Here a is parameter, m is fixed number. If you want to write, you can write it. A is a parameter, m is a fixed number. So anyway, so according to our problem, we have to find the parameter a value. To find it, we have the linear equations. But we know that when we have the linear equations, so if it is in the form of straight line or it is in the form of parabola, to be fitted to the given data. So now this is in the form of exponential. This is exponential form. Definitely we have to convert this exponential form in the form of straight line or parabola. So that means in the form of first degree polynomial or in the form of second degree polynomial. Then only we can have the normal equations. And after, if we have the normal equations, these equations are useful for finding the parameter values. So now we have to take logarithm on both sides for equation 1. Taking logarithm on both sides of equation 1, we get log y is equal to log of ax square. Log a into b. Log a plus log b. Log a plus log b. B is x square. This is equal to log a plus log a to the power b. B into log a. That is 2 into log x. Therefore, log y is equal to this one. Now, take equation number 2. So now we have to convert this into the linear form. That means we have to assume that if log y is equal to capital Y, and log A is equal to capital A and log X is equal to capital X. Then equation 2 becomes capital Y is equal to capital A plus 2 capital X. Capital Y is equal to capital A plus 2 X. Capital X. Is it right, ma?
Yes, madam.
Next, what will we do? Give equation number 3 for this one. So now you can observe that this is in the form of Y is equal to A plus BX as we have discussed just now. Is it right? So that we can say that this is the equation of the straight line or first degree polynomial. You can use any word, straight line or first degree polynomial in capital X and capital Y. So that this can be easily fitted by using the method of least squares approximation. So now, as we have discussed the explanation part in the procedure, the same procedure we can follow while doing the problem also. So now, according to the procedure which we have explained just now, so first we have to find the value of A. To find it, we have the normal equation. So what is M? Y equal to A plus MX. What is M2? This is the fixed number, okay. Only parameter is here, capital A. What is the parameter here? Capital A. How many parameters are there? Only one. So that we have only one normal equation. So for this equation, what is the normal equation? So the procedure which we have followed just now, take that one. The normal equation of equation 3 is summation capital Y is equal to N into capital A plus M into summation X. So summation capital Y is equal to what is N? 4A. According to our given data, how many values are there? N equal to 4. 4A plus what is M from the problem? 2. 2 summation X. So this is the normal equation. This is the normal equation for equation 3. So now we have to find summation X value and summation Y value. So we know that X values from the tabular values. We know that Y values from the tabular values. So from that tabular values, we can find summation X and summation Y. After getting these values, we can find the value of A. So now take this one. Table, tabular values, X values, Y values from the table, from the tabular values. What are the X values, ma? 4, 1, 2, 3. What are the Y values? 4, 6, 10, 8. So is it summation small x or capital X, ma? Small, capital X. Capital X. From the table, from the given table, we have the values of small x, we have the values of small y. But we know that capital X is nothing but, what is capital X, ma? What is capital X? See previous page, what is capital X? Log X. What is capital Y? Log Y. So we know that small x values and small y values. According to the small x values, we get capital X values. According to the small y values, we get capital Y values. So after getting capital X and capital Y values, we can get summation X and summation capital Y. Okay, so now we have the X values and Y values, but we don't know the capital X and capital Y values. Now we have to find the capital X and capital Y values. What is capital X? It's log small x. What is capital Y? Log small y. First, we have to get these values.
Madam, capital Y is equal to log small y. Y is equal.
Yes, right. This is small y. So now use the calculator and find capital X equal log small x. Log 4. What is log 4 value? Tell me, ma. Use the calculator. Logarithm to the base e. Log 4. 1 point. Use the calculator. Find the log value, ma. Log 4. You don't know how to see that, how to find log values by using the calculator?
Actually, I don't have, madam, calculator.
Okay. Anybody? At least one of you. Anybody, ma?
Actually, it is there in the phone, madam. Phone we are using.
Yeah, you can use. You can use. If you scientific calculator, if you have the scientific calculator, definitely logarithm is there.
Yes, it is there, sir.
Yeah, log 4. I'm expecting from you. Okay. Hello, definitely have the calculator, ma, in the subject of numerical methods. Otherwise,
Okay, madam, we will buy.
0.60205.
No, wrong.
Log 4, madam.
Log 4 value, wrong.
I see. Log 4.
Scientific calculator. Logarithm. Where is logarithm? In the phone, can you have logarithm? Log 4 value by using the phone. Is it possible, ma? Yes, we have the possible, ma, by using phone. Okay, do you know how to use from your phone? Tell me, ma.
Trying, madam.
Take the calculator, you know. Do you have in your phone calculator icon? Calculator icon, ma.
Okay.
If it is a smartphone, definitely you have this one. Automatically it has. Open the calculator first. At least one of you open the calculator. Okay. You will have log symbol in that one.
Log 4, it is giving 0.6 only, madam.
No, I'm using here log 4 value. 1.3862 mark. Log means LN symbol. Log means not LG, LN.
Okay.
LG means logarithm to the base 10. LN means logarithm to the base E. That is the difference while using the calculator or whatever it may be.
LN.
LN, logarithm to the base E.
Yes.
Log 4 value. Please tell me at least one value.
2.3862.
Very good. Now, log 1 value, similarly follow this. Log 1 value. 0, ma. We know that. Generally. Log 2 value. 0.6931. I'm using on here. I am following you. I'm using only smartphone calculator. Next, log 3. 1.0986. Next, according to the y values, log 4, same value. Log 6, 1.7918. Log 10, 2.3026. Log 8, 2.0794. I'm using phone here. Did you get it? LN of value. Not LG of value. Take LN. Okay, anyway, see the later. Anyway, I have given the values for capital X and capital Y. And find the summation of capital X, please. Sum of all the capital X values. Tell me.
3.1779. 3.1779.
Okay, 3.1779. Next one.
7.5591.
7.5.
591.
Okay. So now substituting these values in the above. In this one. Now, substitute relevant values in equation. Which equation, mark this one?
3.
4 kada? Normal equation kada? 4 kada? 4. Give equation number 4. Sorry. Here only. Give equation number 4 for this one. Equation number 4. So next.
Okay.
Okay. Substitute that values, ma. Summation y, that is 7.5591 is equal to 4a plus 2 into summation x, 3.1779. 4a is equal to, from this one, we will get 4a is equal to 7.5591 minus 2 into this value. 2 into 3.17, 3.1779 into 2 is equal to 6.3558. So now what is this value? What is this value?
$1.2033.
1.2033. This is divided by 4. Is it right? 0.3008. So anyway, this is a value. And from a value, from capital A is equal to 0.308, we can find the small a value. Small a is equal to, what is small a? From the previous page. Log small a is equal to capital A. From here, we have to assume it. According to this one, right, capital A is equal to log A implies A equal to e power A. So therefore, small a is equal to e to the power 0.3008. Now find this exponential value. .3008 is equal to 1.3509 value. Now substitute this a value in 1. We get y is equal to a into, that is 1.3509 into x to the power m square. This is a required curve to be fitted to the given data by using the method of least squares. Approximation. Okay, ma. Now, in your book, see page number 99 and do the example according to this one, page 99. Same problem is there, follows us.